So the two major contributors to electricity consumption in the US is coal and natural gas, which is why, especially in residential areas such as like apartments where I've experienced, these are the big bills that you'll see is usually natural gas and electricity that utilities aren't really being willing to be paid for. And electricity power, with 34% being from coal and 27% from natural gas, and then 91% of coal going to electricity power, means that these two are very big influencers. Additionally, the average kilowatt hour that the typical Minnesotan will be putting out per year is 790 kilowatt hours, which is significantly less than the American average, which is 1300. As the Energy Information Administration has noted in 2009, most of the energy usage is being done in space heating, and then lighting and other appliances, and then a little bit into water heating as well, meaning that these are the biggest contributors to energy usage and have been pretty consistently even up till the present day now. And as my research will show for my own data, it is pretty consistent with this as well. Here I have the energy usage trends that I have from my yearly energy bill that I got from my parents here, and as seen here, especially in the spring and summer months, you can definitely see that expected trend with energy, where there's less energy usage in those summer months and more in the winter months, from that kind of parabolic formation in the graph here. It's also very clear that our average usage for right now is 1500 kilowatt hours, which is well above that 700, 800 kilowatt hours that average Minnesotans have, and not even including the efficient ones, that's just the average ones. So already we are seeing that discrepancy, and this could be related to that the fact that we are 3 people in this home, and our information online isn't like filled out completely. My parents didn't show, this is our square footage, this is our number of people here. That information's not there, so that could be skewed, as well as the information like what kind of heating and such that we use is not on the Excel energy bill that I could see. It had to be filled out, so that might also not help as well for that. Here I have a couple pictures of me, one using the kilowatt meter on my cell phone charger, and then the other one on my room heater that we have for my basement. On this slide I have the weekly log data that I have found for my appliances that I did measure, excluding the laptop and computer that I also measured that were variable, so I didn't include that in there, although I did try to use as realistic of a measure as I could in those 24 hours, as some days it does vary anyway. And then here I have my weekly log data. I converted into a graph just to be a little more visually stimulating, and a little bit more easy to read than those numbers. So as you can see, the digital clock that I have in my bedroom, my white noise fan, and my cell phone charger were the big users, as well as our basement room heater on a few days of the week. Moving on to my energy use table for all my appliances that I did measure, I did find a few peculiar things that I did not quite expect. Like, one of the things that I didn't know was how much energy a laptop and a computer use, but even the fact that the computer desktop itself uses so much more than a laptop. Especially with my own, I knew that would be true because of how much use it needs to be using because of the uses that I have it for, which is part of one of the jobs that I do with is streaming and gaming and stuff that uses multiple programs at once. That's very intensive, as well as noting the heater being just as impactful as the computer as well. I didn't think it'd be that comparable in how much power it would be using. After looking at all of that data, I've conducted this graph to show how much use is incorporated from each device, and it's very obvious that my basement room heater, computer, and laptop are the big ones, which was expected from previous research studies that had been discussed in this class, where they talked about heating and electrical appliances being those big users, where like my basement room heater used 85.2 kilowatt hours per month out of the 212 that I'd found. So this is a big contributor, and then computers same at 78, very big, and then laptop at 42 with less, but still a very big comparison, with all these other things like the lamps and the cell phone chargers and other small devices not really putting out much energy usage per month. So after reviewing this data that I found from my own home, I decided to look online and see how other appliances compared, and a few of the big ones that I noticed were like the portable heater, which was usually 1.5 kilowatt hours per hour, where mine was 2.8 kilowatt hours for 3 hours, so doing the math, it's quite a bit less than that. The toaster being 0.04 kilowatt hours per use, with mine being 0.01, so it's 25% less. With my desktop computer being much more significantly higher than the 0.25 kilowatt hour per hour, mine being at 2.6 for 8 hours, as I did expect that from how intensive it usually is. And then the laptop was 0.02 to 0.05 kilowatt hour per hour for most laptops, with mine being again higher than that because it is also again very intensive. And then my digital clock was quite less than most clocks, it appears. And then I didn't incorporate other large appliances and variable uses, such as like my refrigerators or freezers, or big appliances like the ovens and stuff like that, that were likely the big contributors to our energy bill, as these are likely the ones that would do most of that consumption. To wrap it up, the major conclusions that I found is that our home is using over 100% more electricity than most similar homes, according to Excel Energy. Most of our smaller devices are efficient, according to the Silicon Valley power statistics that I just discussed in the previous slide. But this does mean that our larger appliances are probably not comparing to other homes, since we are using much more electricity than most other homes. And so this could be because of our house's age, lack of appliance updates, I'm not really sure. Maybe it could just be because there's 3 people and that's not taken into consideration. But it's clear that the best ways to save money and power are through heating and electricity, as expected in the previous studies. And that's everything. Thanks for watching.